Go. Hello. Look, this is yesterday's. We talked about how to check binary tree is symmetric, right? Remember this, yeah? Yeah. So this is the recursion.
Remember?
Yeah. We check if A and B the value, and then its subtrees are also symmetric. Okay. So today we talk about a few things, and then we will come back to these again. Okay. So it'll be very interesting because it will be very interesting. Okay. So first of all, how do you make a copy of a tree? You know, first of all, if I give you a tree, give you a tree.
You copy it the same way. Yeah.
Okay, so Liz, I want you to copy it. You know, copy it. So we make another copy. So this function will be like clone. Okay, you know what's clone? Clone. Clone is the copy. Yeah, to make a clone. Make a clone. Yeah, make a copy. Yeah. So what do you do? Look, the copy in computer we have two kinds of copy. One is called deep copy. The other one is called what? What's the opposite of deep?
Shallow.
Yeah, well done. Deep copy and shallow copy. Deep copy.
Did you get that correct?
Shallow copy. Okay. So can you tell me what's the difference? Deep copy and shallow copy.
They're the opposite.
Yeah, they're opposite. So what's shallow copy? What's deep copy? Can you make a guess?
Deep and shallow.
Yeah. So okay, deep. You can think of it as complete. You know, I want to make a complete copy. So once I copy it and paste it, it will be the same. It will be exactly a copy, right?
Yeah.
So I make another copy, yeah. So these in memory, you'll be different places. So what I mean different places is you can change the things here, but it wouldn't affect here because they are different. Yeah? Yeah?
They look the same.
They look the same, but they're different places. You change this place, you change the value to 7, and this won't be affected. Shallow copy is the other same, and on other cases, it's like alias. Do you get it? It's like alias. So you make a copy of these, then you'll be just another pointer points to that. Okay, so you'll be it's not an individual, it's not an independent copy, right? So when you change the value, like if you change the value here, then you'll be linked to here, it will be also be changed. It's the other way, right? It's like an alias. For example, like I give you another name, like what's your favorite name? Salty Shark, yeah? Salty Shark, yeah? And I call you Salty Shark and then you'll respond. That's called shallow copy. It's like Ryan is a clone of you, right? I call Ryan, right? And then you wouldn't respond because it's different, right? Do you get this point? Okay. So we are now talking about the deep copy.
That's weird.
Deep copy in computer. If a shallow copy. So what's shallow copy? Normally,
What's a shallow copy?
Look. Shallow copy in Python you can just do this. I create a node, right? Root a new node. Like let's say new node. Then you can say let's call it tree. Okay, tree. This is tree, and then return new node. Okay. So you just copy this node, but you are not copying its subtrees, right? You are not copying its subtrees. So its subtree is the same. Is exactly the same as the previous, right? It's just copying a node. But for the clone, let's talk about clone the entire thing, and then you tell me what to write. Okay? It's right. Look, define clone root. Okay?
Clone. Yes.
If root is none,
Yes.
return
None.
wait down. And then I create a new node, yeah? New node equals tree with the root value, yeah? With the root value. And then node dot left equals what? Clone, calling itself, clone the left tree, clone what?
Clone. Root.
Do dot left.
Yeah.
Because we are clone the root dot left. And then new
And
node,
then
new node
Right.
dot right equals what?
clone. Root dot right.
Well done. Very clever.
Very
then-
clever.
The next one.
The next one.
Return
Turn.
what?
Root.
No, we are.
Clone. Right.
Come on, what are we doing
New
here?
node.
New node, yes. New node, yeah? Do you get it? We're
Yeah.
creating a new node with the value, exact value, but we are recursively calling itself to clone its left tree and the right tree, and we're returning the new node, yeah? This is called deep copy. Do you get it? What's the time compressed?
I win.
Well done.
Always.
Okay, so now we talk about another one, which is called check if two trees are the same. Interesting,
Oh.
yeah? We have a two tree. How do we check it's the same? When it's the same, I mean the structure is the same and the values are also the same. Okay? So you
Yeah.
tell me how to do it, okay? Define. Let's call it same, okay?
Same.
Or maybe equal. Same is not quite a good word. Equal, right? Because they are not the same, but they can be equal, right? Yes? Let's call it equal.
Equal.
A, B,
Equal.
and what?
Column.
If A is none and B is none, what should we return in this case?
None.
No, we are returning true and false. Yeah, we are returning a Boolean value here.
Boolean.
Return what?
False. Boolean.
If both trees are empty, we should call it equal. Yeah.
True.
Then if A is none, in this case, or B is none, what should we return? Or.
False.
Yeah, because at this stage, one of them is none, the other is not, right? Then one is something, the other is nothing. Then they must not be equal, right? Alright?
It
Yes?
must be not be equal.
Okay. Okay, then let's say if A dot value not equal B dot value, what should we return?
False.
False, because they are not equal, then we return one. And otherwise we return.
True.
Not yet. We need to check if both subtrees equal A dot what? Left.
Yeah.
And then what? B dot what?
What? Right.
No, we're checking it. Two trees are the same. The left tree will be equal to the right. And then and what? And
Equal.
yeah. A dot what?
Left. No, right.
Right.
Then B dot right.
Yeah.
Wait, just to do something.
Because we need to check both trees. The left trees are equal and the right trees are equal. That's it.
That equal is not spelled properly.
GQ. How do you spell it?
Yeah, we forgot now. This is a bracket code.
Okay. Looks like a bracket. Okay. So do you get it? We need to check the values are the same, and then its left trees are the same, and the right trees are the same. And what are the recursive calls here? Where are the recursive calls?
Ooh.
How many recursion here? How many?
About
How many recursions in this call?
2 or 3.
2. Where's 2? Where's 3? You point them out. Where's the recursion? Where's the call with the equal names here?
Ooh. Yeah. And
These 2, yeah?
yeah, you two.
Yeah.
Oh,
These 2. What's the complexity?
oh,
Yeah, because you need to visit n nodes at the same time, yeah? To be honest, it's not exactly ON. If I tell you, because there are 2 parameters, yeah?
You said
No. Don't make a guess, random guess. This is A, this is B. If I tell you there are n nodes in A, B nodes in N, No, n nodes in A, n nodes in A, B, n nodes in B. So what's the complexity?
NM.
NO times B.
N times M.
No.
N
No. It will be O minimum N and M, right? Right? Because you, for example, if a tree has 10 nodes and another tree has 100 nodes, you just need to check the 10 nodes at most, then you'll find out if they are not equal, right? Do you get it? Yeah. So do you see? Yeah.
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 I.
It's a minimum of in minimum. Okay. So that's it. Don't make a random guess. Okay. When you make a guess of log n, usually involve dividing something into half, right? Do you get it? That's log n, where the log n comes from. Okay, so now we know how to check the trees are equal, and we know how to clone a tree, so how can we check if a tree is... And we also know how to invert a tree, right? Remember, how do we invert a binary tree? Remember? Remember, let's do a review, okay? Invert, yeah? We talked about this before, yeah? Invert root column, okay? Look, if root is none, return what?
Return true.
None.
None. And then left equals invert root of what? Left.
Yes.
And then right equals what?
Read up white.
Invert.
Yes.
Invert root of right. Okay, and then we need to root of left equals right, right? Let's call it invert, yeah? Inverse part, yeah? And root of right equals what? Huh? Root of left equals right. Root of right equals what?
Left.
Yeah, we are inverting, yeah? And then return what? Return what?
True.
What true? You're not making a guess. Return what?
Left. Right. Wait.
You're making it. You're not. What are we doing here? We are returning what? We are returning the root.
I said wait.
Yeah, I know. Look, we are creating the root. We are root, and then we need to assign. That's why you did. Why you say return true or false? Come on, don't make a guess, okay? Now we are inverting. So now how can we check if two trees are a tree is symmetric?
Yeah.
Remember how do we check the symmetric tree? Okay, you tell me, okay? You tell me, okay? Symmetric root, okay? I can do this. Yeah, look. Clone. Let's call it new. Copy, okay? Copy equals clone. Let's clone this tree first, okay? Yeah? Yeah?
Yes.
And then what should we do with it? Then we also need to invert it, yeah? Invert the tree, okay? Yeah? And then how do we check if the two trees are if the tree is symmetric?
All you need to do is just
Wait, look. Return equal, you tell me, equal what? Equal two things put here.
root.
Okay, one of them is root, the other one is. You make a guess, come on. Equal root and what? We are comparing the root with the
White.
Clone. Clone, yes. Copy. Do you get it? Look, we copy the tree, right? And Eric, we copy the tree, we invert it. And if the invert version is the same as the root, then it's symmetric. Am I right? Yes? Am I right? Look.
Am I right?
2, 3.
4.
Look,
4.
if this is the root, okay?
5.
We make a
5.
copy and then we invert this. What's invert? Invert version will be 1, 2, and then what? It will be the same as this one, yeah?
Yeah, exactly.
So because that, and then you check if these two are the same. If the same, it's equal, it's symmetric. Got it?
Yeah.
Do we have to clone it?
No.
We actually don't need to clone it. Why? Can I have the eraser, please? Look, If we allow to modify it, we can just do this. Okay, you tell me, okay? Return as the same, equal what? Root the left,
Plus.
then something here.
Really dot right.
No, of course
Right.
no. Why is
Left,
it?
right.
No. There's something
Clone.
invert. Root the right. What does it mean?
Ooh.
Look, if a tree.
Going down means.
Look, let's do this. Look. This rule, we want to check if it's symmetric. We can compare its left tree, right? And the right tree. We need to invert the right tree. Invert the right tree, you'll be this. Yeah? Then, if they are equal, then it's symmetric. Do you get it?
Yeah.
Yeah. If you're comparing the root of right, then it must not be equal, right? Right? Because this you'll be like that, and this is not symmetric at all, right? Okay? What's the complexity?
O-N.
For most binary
O-N.
trees, yes, it's O-N because you need to visit the trees n times, linear number of times. So do you get it?
Linear.
So what do we learn today? Can you review a little bit?
About
What kind of function do we learn today?
clone.
Clone. We know the deep clone and shallow clone. Can you tell me what's deep clone? What's shallow clone? What is sheer copy? Deep copy, shallow copy. Just in one word. Come on.
Copy.
What's the deep copy? And what's the difference between deep copy and shallow copy?
It is a clone.
So if a tree, I want to make a copy exactly, then you'll be another tree, totally independent. Yeah? If you make just assign a node to it, a copy of the node, yeah, and then you visit this copy dot left, you'll be pointing to this. Do you get it? This is called shallow copy. Yeah. And apart from the clone method, what do we learn also?
About
We check if two trees are
symmetric.
yes, symmetric and also equal, right? This is equal, right?
Yes.
And then we also know we invert. We know how to invert the binary tree, yeah? Yeah. Based on these three, we also can know how to do this symmetric, yeah? Symmetric. Do you get it? So these are the four things we have visited today. Yeah, we have visited today. Got it? Yeah? Do you understand? Yes? Okay.
Yes,
good
I
job.
understand.
Okay, wait.
Oh, wait.
Okay, that's it.
Bye.